Welcome to the session on representations of data, histograms. The objectives for this session are to draw and interpret histograms. A histogram can represent grouped continuous data. Histograms allow you to observe a variety of things, including how data is distributed, a rough location of the data, the general shape and spread of the data. Area of each bar in the histogram is proportional to frequency in each class, allowing representation of data with unequal class widths. Let's illustrate this. The height of each bar in the diagram shown is calculated as follows. Frequency density equals frequency divided by class width. When class width is 1, we have a bar chart. We can join the middle of the top of each bar of the histogram to form a frequency polygon, as shown. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve part A first. A random sample of 25 drivers with driving offences were asked their age. The ages were recorded in the table shown. We are required to draw a histogram and frequency polygon to represent this data. We're going to begin by finding the class width. Now, notice the categories. The categories don't go up by the same amount each time. The first category goes from 17 to 20, and then the second one goes from 20 to 30, the next one 30 to 40, then 40 to 50, and then 50 to 60, and then the last one goes from 60 to 80. Now in this situation it would make sense to allow class width to be denoted as 1 for a category of size 10. So an interval of size 10 represents a class with width of size 1. Here, 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 and here. And therefore, the 17 to 20 category is of size 3/10, and the 60 to 80 category is of size 2 because it's twice as big. So we can now find the frequency density, which from our formula is of course frequency divided by class width. So for the first category, frequency is 3 and class width is 3/10. So 3 divided by 3/10. For the second category, it's 5/1, then 6/1, then 2/1, then 3/1, and finally 4/2. So frequency density, once calculated, is that shown in the last column of the table. And so we can plot this or present this as a histogram. Here's the first category, drivers who are between 17 and 20 years old. And for 20 to 30-year-olds, 30 to 40-year-olds, 40 to 50-year-olds, 50 to 60-year-olds, and finally 60 to 80-year-olds. We can now join the midpoints of the bars in order to produce a frequency polygon, as shown. And this will look something like this without the presence of the histogram. Now for part B. We're required to estimate how many drivers were between 32 years and 45 years old. Here's age 32 and age 45. And the people between these ages have been shaded in a darker colour. The shaded area here is equal to 40 minus 32 multiplied by 6, which is the height of the rectangle. And the shaded area here is 45 minus 40, which is the width of this shaded rectangle, multiplied by 2, which is the height. And this equals 58. So approximately 58 drivers are between 32 and 45 years old. This brings us to the end of this session. If you have understood its contents, you should be able to draw and interpret histograms. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.